So in this example, we have congruence modulo n. That's this right here. And congruent is similar to equivalent. We use this three-line equal sign to show that expressions are equivalent or congruent to each other. And congruency shows that there is a relationship that is compatible between the outcomes. So, for example, suppose we had 25 modulus 4. 25 mod 4, 4 goes into 25 6 times with a remainder of 1. So 25 mod 4 is 1. And then if we had 49 mod 4, 4 goes into 49 12 times with a remainder of 1. So then we can say that 25 modulo 4 is equal to 49 modulo 4. So we have a shorthand way of being able to express this. And the shorthand way is we can write it as 25 is congruent to 49 mod 4. And here is that three-line equal sign. That means congruent. This can also be written as 49 is congruent to 25 mod 4. Either way is fine. Now the parentheses mean that the modulus applies to the entire equation, not just to the right-hand side. And these notations here are not to be confused with these notations here. These notations here show the actual operation. These notations here show the relationship. So for letter A, it says determinant of 58 is congruent to 170 modulo 8. So I'm going to put A right here. So we have 58 modulo 8. So 58 mod 8. And using the division algorithm, we have 58. Now you could certainly use your calculator, but you should think about what's going on. We know that 8 divides into 58 7 times. 7 times 8, that's 56. Plus 2 with a remainder of 2. So 58 mod 8 is equal to 2. We'll do the same for 170 modulo 8. So 170 mod 8 using the division algorithm. 170 is going to be equal to, so we have 170 divided by 8. Don't forget, we round down. 21 times 8. 21 times 8. That's 168. Plus 2 will give us 170, so this has a remainder of 2. So since 58 mod 8 is equal to 2 and 170 mod 8 is equal to 2, we can write this as 58 is congruent to 170 mod 8. We could also write it as 170 is congruent to 58 mod 8. Either way is fine. Now there is a way to check, and that is if we take the difference between our dividends here and divide it by 8, 8 should divide into it equally. So if we take 170 minus 58, that's equal to 112. If we then divide that by the modulus of 8, that's 14. So 8 times 14 will give us 112, which is the difference between these two. So we know that we did our process okay. Let's try B. Determine if negative 29 is congruent to 48 modulo 11. So negative 29 mod 11. Negative 29, it's going to be equal to, using the division algorithm, negative 29 divided by 11. And don't forget, we round down, so this is going to be negative 3 times 11. Negative 3 times 11 is negative 33. So then we add 4. So negative 29 mod 11 is 4. We'll then do 48 modulo 11. Using the division algorithm, 48. 11 goes into 48. Isn't that 4 times, right? 4 times 11, that's 44. Plus 4, so 48 mod 11 is also 4. So we can write this as negative 29 is congruent to 48 mod 11. And again, we could also write it as 48 is congruent to negative 29 mod 11. For C, determine if 97 is congruent to negative 25 modulo 18. 97 mod 18. (97) is going to be equal to, divided by 18. That's going to be 5 times 18. And then 5 times 18, that's 90. Plus 7, so the 97 mod 18 is 7. We'll then do negative 25 modulo 18. Negative 25 modulo 18, that's negative 25 using the division algorithm. Now don't forget that we have a negative here. So when I do negative 25, divide that by 18, we round this down to negative 2. Sometimes students think that 18 will go into negative 25 one time, but don't forget we have to do that rounding. So this is going to be negative 2 times 18, and negative 2 times 18 is negative 36, so then we would have to add 11. So this is 11, so negative 25 mod 18 is 11. So we can say that 97 is not congruent. We can do the congruency sign with a line through it to negative 25 mod 18. We could also write this as negative 25 is not congruent to 97 mod 18. Either way is fine. And finally for D, determine if 2,356 is congruent to 1,201 modulo 21. 2,356 modulo 21. 2,356, that's going to be equal to 2,356 divided by 21. That's 112. When 12 times 21, that's 2,352. So then our remainder is 4. And then 1,201 modulo 21. Using the division algorithm, 1,201, it's going to be equal to 57 times 21. That's 1,197. So we have a remainder of 4. So then we can state that 2,356 is congruent to 1,201 mod 21. And don't forget, we can check the difference between our dividends here divided by the modulus should go in evenly. So we'll do that. We'll take 2,356, that's this right here, minus 1,201, that's this one right here. It's 1,155. We'll divide that by 21. And it does go in it evenly, so I guess everything's okay. And there we go.